Hello. With this short video, we're finishing the course on data science for business. Well, it's worth to understand that the role of data in business in general. There are actually could be three different roles. One is we can use data to help formulate business strategy. And business strategy is really a set of particular discrete decisions that are leading positions of strategic advantage. And that is when data is being used by the company leadership. We can also use data as a strategic asset, which is, example is for Google or Amazon, where the data allows us to build something nobody else can build. And third is using data to make operational improvements, to improve efficiency, speed of operations, cost of operations. Now, the third topic is what we pretty much covered in our lectures. We looked for the use of data and machine learning, data science within operations. So in fact, we were focusing mostly on retail analytics topics. And the reason that they cover most of the techniques that you'll need to learn. And in fact, if you ever look for the career in data science, most of the positions will somehow be related to type of retail analytics. If you look at this, we talked about various algorithms from regression, classification, clustering, dimensionality reduction. We talked about time series analysis. We talked about recommender systems. And we also touched upon two technical topics. One is natural language processing and large language models. Something that is like very, very new topic. And we also looked at the simulations and agent-based modeling. With those techniques, we actually looked into several use cases from customer churn management, segmentation, personalization, sales forecast. Now, as a data scientist who is writing algorithms, it's important to understand where the algorithms are being used. On one hand, your algorithm can be used for decision making. That's the end users of those algorithms are usually the decision makers, which are the business owners. Those people who are taking the results of the data, and it can be sort of one-off result, and making particular decision. And they're drawing conclusions from the data, and then operating the company based on that. Now, the role of data scientists in this case is to understand the business problem, design and implement different metrics, run experiments, create dashboards, draw conclusions, deliver and discuss results. So in this case, data scientist works a lot as a consultant, helping business leaders to make decisions. On the other side, could be data science for production. That is when we, as a data scientist, develop and deliver algorithms. And those algorithms are being placed within the production system. So in this case, the goal is build proof of concept or MVP for the product. And the data scientist role here is develop algorithm, train them, test them, deploy them into production system, and then hand it over towards to operations. So in this case, a data scientist really works more as of machine learning or software engineer. So there is this two sides of the data scientist job, right? Data scientist as a consultant and data scientist as a machine learning and software engineer. But whatever role you take on, there is the data science approach follows always the same modeling pipeline. We start with data understanding, and usually, we're provided with data by business owners. Then we spend time preparing the data, extracting the data, massaging it, cleaning it, putting it into the right format, aggregating it. Then it's time for model development and training. And here you kind of iterate within yourself within the data science world, where you want to make the data work. So you want to make the model that works the best on the data you have. Then you go into validation. Again, here There are several ways of doing it, several layers. Of course, first of all, you do it within the data set you have, but then you can actually bring in external human validator to make sure the model works. And, often model doesn't work from the first time. Then you come back to, for example, understanding data or requesting more data or do something else. And you iterate until, the model passed all kind of evaluation and validation tests. And finally, if we are within the sort of the first paradigm of being consultant, we're pretty much using the model to get the insights and deliver insights. And if we are working in this paradigm of a machine learning software developer, then it's time to hand over the model to IT ops and helping them deploy it. There are a lot of tools that are available for data scientists. And, we looked at some of them from low code and visual flow systems to Python, Pandas, Jupyter notebooks, etc., etc. Now, what we are seeing currently is a very, very fast development of various support tools like AutoML, so systems that automatically allows you to tune up parameters of your algorithms. But what currently happens is even more than that. With this amazing development within generative AI and large language models that are capable of not only writing code for us, but also setting up problems, delivering plans, executing plans, and some of the reasoning, it becomes clear that most of the professions and most of the jobs very soon will be disrupted and will change. And so it looks like even for the data scientists, the importance of knowing syntaxes of the language becomes less and less. That becomes less and less needed. You can use tools like ChatGPT to help you actually write code. But in fact, those tools can not only write code, but it looks like they can help you even to think about the problem, to reason about the problem, and to kind of create an outline. What they cannot do, they cannot take your business problem, convert them to and convert them into the data science problem. They can help you to solve the data science problem. But the first part is really on you. And so which means you still need to have a good understanding of business, and you still need to have good understanding of approaches to solve problems. But the technical part of actually like writing code, bringing in the data, cleaning data, et cetera, that probably will be done by the algorithms and will be done very, very soon. That also democratizes access to AI, which means with less technical skills, you'll be able, and other people will be able to do much more and build systems and algorithms without actually knowing how to program. So I would strongly recommend you guys learning how to use, prompting for ChatGPT and try to use it in sort of almost daily life. There will be more and more algorithms and programs like that, tools like that coming out in a very recent future, and that's probably the future of any profession. To sum up, there are a lot of books out there. There are books that are more of sort of general view, like Data Science for Business or Predictive Analytics. These books I just recommend again for reading to sort of, expand your knowledge, expand your horizon. If you want to learn more technical stuff, the wonderful book is Introduction to Statistical Learning, Applied Predictive Modeling. These are the books that tells you about algorithms. And finally, there is, of course, a lot of books on hands-on programming that works if you want to be more on a software engineering side. And of course, at this moment, with this extremely fast development of large language models and ChatGPT types of algorithms, go on the web and look and read all the manuals, because that's where all the information is. There's still no books that I could recommend on that topic. Go to the sites of the developers of the models, look into the blogs. And last but not least is to remember, when you are actually as a data scientist working for the company, to deliver business impact, you need to remember that there are more steps than building algorithms. In fact, it has been noticed that, you know, the algorithms, though without them you cannot do anything with the data, they probably might take, you know, 10% of an effort to put things together. 20% of an effort goes into building technology around algorithms, and 70% often goes to change management. Now, I'm not talking about the industries like, you know, search engines or high-tech industries. I'm talking about retail type of industries where they have a lot of people involved in the processes. And so working and making those people use your algorithms and making those systems work well takes a lot of efforts. So again, you know, the data science effort is important. It's critical. Without it, nothing's going to work. But don't forget that in order your algorithms to make it into life, there are many more efforts from you and other people required in terms of building technology on top of your algorithms and doing change management, which is making people use your algorithms within their business processes. All right. So with that, we're finishing up with the course. I hope it was interesting and useful, and you know, good luck with your data science careers. And thank you very much. Thanks for watching. Bye-bye.